Episode 104, titled Firewall Rule Design, SRC/DST, allowlists/blocklists, app-aware logic, we treat rule design as translating intent into enforceable policy, because a firewall rule is only useful when it expresses a clear security intention in a way the device can execute consistently. The exam often expects you to reason from a described flow to a rule set, and the best answers show that you understand how to express who should talk to whom, for what purpose, and under what constraints. Poor rule design is a common root cause of both outages and security exposure, not because firewalls are unreliable, but because ambiguous intent turns into permissive rules that bypass segmentation. When you design rules with clarity, you reduce troubleshooting time, reduce drift, and improve the ability to validate that controls are working as intended. The goal is not to create the longest rule set, but to create the smallest set that accurately enforces the intended flows. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Source and destination are the core of a firewall rule because they define who talks to whom, which is the fundamental segmentation question. Source identifies the initiating side, such as a user segment, an application tier, a management network, or a specific service identity translated into an address or tag depending on the platform. Destination identifies the target, such as a database subnet, an external service, or a specific host or load-balanced endpoint. Getting source and destination correct is crucial because a misscoped source can grant many systems access that only one system needed, and a misscoped destination can open paths to entire segments instead of to a single service. The exam tends to reward the idea that segmentation is enforced by narrowing who can initiate connections and where those connections can land, not by hoping that internal traffic is safe. When you start with source and destination, you anchor the rule in the architecture's trust boundaries rather than in protocol trivia. Ports and protocols define what services are permitted, and they translate what kind of conversation is allowed between the source and destination. Protocol tells you the type of traffic, such as transmission control protocol or user datagram protocol, and ports indicate which service endpoint is being accessed, such as a database listener or a web service port. This matters because allowing any port between two segments effectively removes meaningful control, while allowing only the necessary ports enforces least functionality and reduces the attack surface. The exam often expects you to recognize that ports are a coarse control and that modern environments use many protocols over common ports, which is why you must still scope source and destination carefully even when ports look benign. Protocol also matters for stateful behavior because stateful firewalls track connection state and allow return traffic differently than stateless filtering, affecting how you express inbound and outbound requirements. When you define ports and protocols precisely, you make the rule enforceable and testable rather than vague. Allow lists are safer as a default because they enforce only what is needed rather than everything except what we remembered to block, and that difference drives long-term security posture. An allow list approach starts from deny by default and then adds explicit permits for required flows, which naturally supports segmentation and reduces accidental exposure. Blocklists can be useful as limited exception tools, such as quickly blocking a known malicious destination or temporarily restricting a risky category. But block lists are fragile when used as a primary model because attackers can shift to new destinations and because the list must be constantly updated. The exam tends to emphasize allow listing because it is aligned with least privilege and because it scales better for predictable internal flows. Block listing is often most appropriate as a supplemental layer, especially at egress points, where you may block known bad destinations while still relying on allow lists for sensitive segments. When you treat allow lists as the backbone and block lists as targeted supplements, your policy stays coherent and easier to audit. Application-aware rules add another dimension by restricting based on application behavior rather than only on ports, which is important because port-based control alone cannot always distinguish legitimate use from abuse. Many applications use common ports, such as Hypertext Transfer Protocol Secure, and attackers can tunnel malicious behavior through those ports, making port-only rules too permissive if they are the only control. Application-aware inspection can identify specific applications, sub-protocols, or behaviors and enforce policy that allows the business-required application while blocking risky functions or unknown traffic patterns. This is especially useful at choke points where multiple flows converge because the firewall can apply consistent application layer policy without relying on every endpoint to behave perfectly. The exam often frames this as next-generation firewall capability, where the firewall understands more context than just addresses and ports. When you use application-aware logic, you are reducing ambiguity in allowed traffic and making it harder for attackers to hide inside allowed ports. Ordering rules from most specific to least specific improves clarity and reduces unintended matches, because many rule engines evaluate rules in sequence and stop at the first match. Specific rules should capture the precise flow you intend, such as a single application tier talking to a specific database service on a specific port, while broader rules should be minimized and placed later so they do not swallow traffic that should have been handled by tighter policy. This ordering also helps troubleshooting because when a flow is unexpectedly allowed or denied, you can trace which rule matched first, and specific rules are easier to validate. The exam expects you to understand the concept of precedence because a good rule set is not only about what you permit, but also about ensuring that the intended rule is the one that actually applies at runtime. Ordering also reduces the temptation to create catch-all permits early in the list, which is how segmentation quietly collapses. When you order by specificity, you preserve intent and reduce policy surprises. Consider a scenario where you want to permit an application tier to reach a database while blocking lateral access, which is a classic segmentation design and a common exam pattern. The application tier needs to connect to the database service on a specific port, and that flow should be explicitly allowed from the application tier sources to the database destination with only the required protocol and port. At the same time, you want to block lateral movement, meaning you do not want the application tier to talk freely to peer systems or unrelated internal segments, because that would enable pivoting if an application host is compromised. A well-designed rule set allows the required app-to-database flow, denies other east-west paths by default, and logs denied attempts so you can detect unexpected behavior that might indicate scanning or misconfiguration. This approach keeps business functionality intact while preserving a tight blast radius. The exam expects you to recognize that segmentation is not block everything, but permit only what is required and deny the rest deliberately. Overly broad rules are a common pitfall because they quietly bypass segmentation while appearing to solve a short-term connectivity problem. A rule like allow any from internal to database network may fix an outage, but it also grants access to systems that never needed it, turning a protected database segment into a broadly reachable target. Broad egress rules are similarly risky because they allow compromised systems to reach arbitrary destinations, enabling command and control and exfiltration paths that would otherwise be constrained. These rules often survive because they reduce support tickets, but they create hidden security debt that is discovered only after an incident. The exam often tests your ability to spot these broad rules as risky because the best practice is to narrow scope and document intent rather than to solve problems with permissive exceptions. When you avoid overly broad rules, you protect the network's trust boundaries and reduce the attacker's freedom. Shadowed rules are another pitfall because rules that never get hit create confusion, waste effort, and can hide misordered policy that produces unintended matches. A shadowed rule is typically placed below a broader rule that matches the same traffic, meaning the later rule is effectively dead code. Dead rules make troubleshooting harder because engineers may expect a particular rule to control a flow, but the system is actually matching an earlier rule, leading to false assumptions and slow incident resolution. Shadowed rules also create maintenance risk because teams may update a dead rule thinking they have changed behavior, only to find that nothing happens because the rule is never evaluated. The exam expects you to recognize that rule sets must be maintainable, and maintainability includes eliminating unused rules and ensuring ordering reflects intent. When you keep the rule base clean and ordered, policy becomes easier to reason about and safer to change. Quick wins include documenting purpose and owner for each rule, because documentation is how intent survives team changes and how exceptions are prevented from becoming permanent vulnerabilities. Purpose should state what business or operational need the rule supports, and it should be specific enough that a reviewer can decide whether the rule is still necessary. Ownership should identify who is responsible for the rule's correctness and life cycle, because unowned rules tend to linger and drift, especially after incidents and migrations. Documentation also supports audits, because auditors and security reviewers often need to know why a flow exists, not merely that it exists. The exam frequently rewards this operational discipline because it reflects how mature environments prevent policy sprawl and reduce risk over time. When each rule has a purpose and owner, removing stale rules becomes easier and less politically fraught. Operationally, reviewing logs validates that rules match reality, because the best designed rules still need feedback from real traffic to confirm they are neither too permissive nor too restrictive. Log review can show which rules are frequently hit, which are never hit, and which deny events occur repeatedly, indicating either misconfiguration or attempted abuse. It can also reveal unexpected flows that were not part of the intended architecture, which can be a sign of drift, shadow IT, or malicious scanning. Logs also support tuning because you can adjust rule scope based on observed patterns, such as narrowing a source range or tightening a destination set, without breaking legitimate traffic. The exam expects you to connect logging to continuous improvement because firewalls are living controls and their effectiveness depends on ongoing validation. When logs are used as a feedback loop, firewall policy becomes a managed system rather than a static artifact. A memory anchor that fits firewall rule design is who, where, what, why, and logging, because it captures the essential elements that make rules enforceable and maintainable. Who maps to the source identity or segment initiating the traffic, where maps to the destination service or segment, and what maps to ports, protocols, and application-aware constraints that define the permitted service. Why captures the business purpose and the owner who can justify and maintain the rule, preventing drift and legacy exceptions from accumulating. Logging ties it all together by providing evidence that the rule is being used as intended and by revealing unexpected matches that require investigation. This anchor is useful for exam questions because it gives you a structured way to draft or evaluate rules quickly. When you apply it, you naturally avoid broad, undocumented permissions, and you build a policy that can be audited and improved. A prompt-style exercise is drafting 3 rules from a described flow, because the exam often presents a simple architecture and asks how to enforce it. In a typical 3-tier flow, one rule allows inbound web traffic to the web tier from the perimeter entry point, scoped to the necessary protocols and ports, with logging to observe anomalies. A second rule allows the web or application tier to reach the database tier on the specific database service port, scoped tightly to the application tier sources and the database destination, preserving segmentation. A third rule denies or restricts lateral access from the application tier to unrelated internal segments, enforcing least privilege and limiting pivoting opportunities if the application tier is compromised. The exact expression depends on the environment, but the pattern is consistent. Explicitly allow required flows and explicitly deny or default deny everything else. Practicing this exercise builds the ability to translate a narrative flow into enforceable rules, which is what the exam is measuring. Episode 104 concludes with the idea that good firewall rule design is disciplined translation from intent to enforceable policy, built on precise source and destination, constrained ports and protocols, and application-aware logic where it adds meaningful clarity. Allow lists provide the safest default posture, while block lists are best used as limited, targeted exceptions. And rule ordering from most specific to least specific preserves intent and reduces surprises. Avoiding overly broad rules and eliminating shadowed rules prevents segmentation from quietly collapsing and keeps troubleshooting grounded in reality. Documenting purpose and owner for each rule and validating behavior through log review turns firewall policy into a maintainable system rather than a pile of legacy exceptions. The rule review rehearsal assignment is to take an existing or representative rule set, identify one broad rule to tighten, identify one shadowed rule to remove or reorder, and narrate the intended flows that the revised policy will enforce. When you can do that narration clearly, you demonstrate exam-ready understanding of how rule design supports both security and operational clarity. With that mindset, firewall rules become a precise expression of architecture, not an accidental outcome of past tickets. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.